So in this video we want to evaluate the integral using a trig substitution. Got the integral of 1 over x times the square root of 4x squared plus 9 dx. There's three main substitutions that we could use. If the integrand has a radical in this form, for the first case here, the square root of a squared minus u squared, or the square root of u squared minus a squared. Here u is the variable, and u could be an expression involving x. It could be something like 2x or 3x. A is a constant. The other form, if it has the square root of u squared plus a squared, and this radical could be in the numerator, it could be in the denominator, then we would use this setup. This expression here, u, would be this side here, and then secant of theta would be u over the adjacent, or the hypotenuse over the adjacent side. And for the third case, tangent of theta would be the opposite over the adjacent. So this would be u over a. In our case here, it fits this format here, u squared plus a squared. So that's the setup we're going to use. And now make sure that there's not an easier way to do it, because sometimes you look at this radical and say, okay, it's got to be a trig substitution. Now if this x were up here in the numerator, then it would be your standard u substitution, and that'd be a lot easier than using a trig substitution. In this case, the way it's set up, this would be, I could actually write this, 4x squared as 2, parentheses squared, and I could write the 9 as 3 squared. So in this case, in the method we looked at, this would be your u right here. 2x would be the u, and a would equal to the 3. And that's what we're going to set up here. So in the triangle that we're going to use, we have the u opposite side over here, and then the a would be 3, and this is the setup we would use. So we have then tangent of theta would equal to 2x over 3. Now if I take the derivative here, the derivative of tangent would be secant squared theta d theta. So what we're going to do, just like we do with the regular standard u to u substitution, is we let u be something, and we want to transform the integral into something in terms of u instead of x, so that we can find maybe an easier way to find the value of the integral. Derivative of the right side will be just 2/3. This will be dx. And solving for dx, we have then secant squared theta d theta, and I multiply here by 3/2 to cancel this out, so multiplying through by 3/2. This will cancel this out, put it over here on this side. So in the integral that I have, I'm going to replace the dx by this expression here, and I'm going to get the answer in terms of theta, and then I'm going to come back to this triangle here to write the answer in terms of the original variable, just like we do in any kind of substitution. Now let's look at this part here. The square root of the integral was, or the radical rather, was 4x squared plus 9. So this is equal to, and let me do this also here. I want to solve this for x, so x is going to equal to, again multiplying here by 3/2 throughout, I get 3/2 tangent theta. So that means I can replace the x in the integrand by 3/2 tangent theta. And I also need a replacement for this radical, so let's look at this. This is the square root of 4, and then x can be replaced by 3/2 tangent theta. And this is squared plus 9. Okay, so here's what's going to happen. I'm going to square this 3 here, and this 2, this is in the parentheses. It will give me 9 over 4, and the 4 here is going to cancel. So I'm going to have left here a 9. If I square this out, multiply by 4, this will become a 9 tangent squared theta plus 9. Now I'm going to factor out the 9. I get 9 parentheses tangent squared theta plus 1. And then I'm going to take the square root of the 9. That comes outside the radical then, so this will be a 3 out here. And then inside the radical, under the radical, this becomes a tangent squared theta plus 1. After I factor out the 9 and take the square root. But tangent squared theta plus 1 is the same thing as secant. That's one of your basic identities. That's going to be secant squared theta. Put it equals here. And I have the integral of, in the numerator I have dx right there, and a 1. So I'm going to replace the dx by what I got here. So this will be 3/2 secant squared theta d theta. So now I have the numerator in terms of theta. Okay, in the denominator I have x. So we said x is this right here. So let's replace it there. This will be 3/2 tangent theta. And then the radical can be replaced, taking the square root here of secant squared. This is equal to 3 secant theta. Square root of secant squared is secant theta. So this would just be a secant theta. And I got the 3 also. But let's do this first. We know the 3/2 are going to cancel. These are going to cancel. And then I've got the 3 from right here, from the square root of 9. So I bring this 3 over here. Now we're ready to work the problem out. Let me clear some of this stuff here. We don't need this. Okay, so let's look at this here. This secant theta is going to cancel with one of these. So this would just be secant theta. So this one's gone. This one canceled one of the ones in the numerator. So let me just take it out. That canceled. I got secant theta in the numerator. And remember that tangent is the same thing as sine over cosine. So if I take that to the numerator, let's do this. So I'll do it on the side here. Secant theta. And let's just multiply the denominator by cotangent. The other ways to do it, I could just multiply it by the reciprocal of sine over cosine. Let's just do this. These are reciprocals, so tangent times cotangent will give me 1, but I got to multiply the numerator also by cotangent theta. But cotangent theta is the same thing as cosine of theta over sine. Of theta. And secant and cosine are reciprocal, so this is the same thing as 1 over cosine times cosine, so that they cancel. So secant theta times cosine theta, that goes to 1. It goes to 1. So in the numerator then I have 1 over sine. 1 over sine. But 1 over sine is the same thing as cosecant theta. So this is cosecant theta d theta. So everything else canceled out. Remember the tangent I multiplied by cotangent, numerator and denominator, so these actually canceled out to 1. So that's all I have left. Now we just integrate this. What is the integral of cosecant theta d theta? Well, there is a formula for this one. This can be derived, but most instructors will let you use the formula list, just like this formula lists the solutions or integrals for the integral of sine, cosine, and so forth. I don't need this, so we just go directly to the formula then. Oh, I forgot the 1/3 here. So this has the 1/3 here, so this is actually 1/3. I'll put it outside here. So this will be 1/3. And the antiderivative or the integral of cosecant theta d theta is a negative And I'll put the negative with the 1/3. I'll put it out here. Negative natural log of absolute cosecant theta plus cotangent theta. And then I have the constant of integration. So again, the solution is minus 1/3, or actually not the solution yet, but up to this point we have negative 1/3 natural log of absolute value of cosecant theta plus cotangent of theta plus the constant of integration. The other thing we have to do now is just convert to the original variable. We have the answer in terms of theta. We want it in terms of the original variable, which is, of course is x. Let me put my equal over here. So follow up. All I'm going to do now is just transform this expression here. So the answer then is going to be negative 1/3. It's the natural log of absolute value of, and it's cosecant of theta. So you go to the triangle now. Cosecant of theta is the hypotenuse, which is 4x squared plus 9, divided by the opposite side of the angle, theta. So this will just give me 4 x squared plus 9 over 2x plus cotangent. Just look at the triangle. Cotangent is the adjacent over the opposite. So this will be in reference with the angle here. So opposite, or the adjacent rather, over the opposite, so would be 3 over 2x plus the constant of integration. This is your answer. Now, since we have the same denominator here, I could just write 4x squared. This is actually the square root. This is the square root here. You notice this squared is a right triangle, so this squared, hypotenuse squared, should equal to the sum of the squares of the other two sides. So if I square the hypotenuse, I get 4x squared plus 9, and then square this, 4x squared plus 3 squared is 9. So this, I need to put difference, this should be a square root here. That's the square root right there. And like I said, since I have the same denominator here, I could just write this as the square root of 4x squared plus 9 plus the 3 all over 2x. I'll just leave it in this format here. I want to again caution you that when you're working these types of problems, make sure you look at the problem carefully. There's some that can be done by a trig substitution, or just using the standard U substitution, which is in general much easier and quicker. But in this case, this is your solution using this particular trig substitution. Thanks for watching. We'll see you next time.